Stop. Look at the nearest clock. Watch the second hand tick. Tick, tick. You think you're watching time pass, right? You think time is this invisible river flowing in the background, dragging the universe along with it. You think that if we froze the universe, time would keep going. Wrong. That is not what time is, and that is not what you are seeing. Here is the part nobody tells you, the secret that keeps physicists up at night. Time does not move. Things move. And for 99% of the things in your life, your heartbeat, the atoms in that clock, the thoughts firing in your brain right now, there is only one reason they move: light. I don't mean the light from a bulb. I mean the electromagnetic force. If I could snap my fingers and turn off light, switch off the electromagnetic interaction, physics tells us something terrifying would happen. Your clock wouldn't just go dark, it would stop existing as a clock. Your brain would stop processing now. The universe wouldn't end, it would just pause. So, does time require light to exist? Is the speed of light actually just the speed of time? Close your eyes. I'm going to show you that you aren't just seeing with light, you are ticking with it. Let me show you. Let's start with a simple question. What is a clock? Most people think a clock measures time the same way a ruler measures length. You put the ruler down and it tells you how long the table is. You look at the clock and it tells you how much time has passed. Wrong. That is the mistake everyone makes. A ruler measures something physical that is sitting right there. A clock does not measure time. A clock counts events. It counts ticks. It counts swings of a pendulum. It counts the vibration of a quartz crystal. It counts change. Here's the thing. If you take the battery out of your wall clock, the hands stop moving. Did time stop? You'd say, no, obviously not. My watch is still running. Okay, what if we stopped your watch? What if we stopped the sun from moving across the sky? What if we stopped your heart from beating? What if we stopped every single atom in the universe from vibrating? If absolutely nothing changes, not a single particle moves, does time still exist? Close your eyes and imagine this. Imagine a universe that is completely empty. No stars, no gas, no light, just void. Now imagine waiting 1,000 years. Here is the problem. In that empty void, there is no difference between 1 second and 1 billion years. Without an event to mark before and after, time is meaningless. That sounds like philosophy, but it's actually cold, hard engineering. Time isn't a container that the universe sits inside. Time is just the frame rate of reality. Think of a movie. A movie feels like a continuous flow of time, right? But if you zoom in, it's just static pictures flashing 24 times a second. Change the picture, time moves. Freeze the picture, time stops. So for time to exist, we need the picture, quote-unquote, of the universe to change. We need matter to move. We need atoms to jiggle. But what pushes the atoms? What forces the next frame to load? This is where your intuition fails. Because the engine driving almost every change you have ever seen isn't gravity. It isn't nuclear force. It's something much faster. Do this right now. Lift your hand and press it firmly against the table, or your leg, or the arm of your chair. Push down, hard. You feel that? That solid pressure? That resistance stopping your hand from passing right through the material? You think you are touching the table. Wrong. You have never touched anything in your entire life. You are hovering. Let's zoom in, way in, past your skin cells, down to the atoms. You remember high school chemistry? An atom is a tiny nucleus surrounded by a cloud of electrons. Electrons have a negative charge. When you bring your hand close to the table, the electrons in your skin are getting dangerously close to the electrons in the wood. And what do two negative charges do? They repel. They push back. That solid feeling you have right now isn't matter hitting matter. It is a force field hitting a force field. It is electromagnetic repulsion. You are floating on a microscopic cushion of energy, about 1 nanometer above the chair you're sitting on. But wait, don't scroll past this, because this is where your intuition lies to you. How do those electrons push each other? Do they have tiny hands? No. In physics, forces don't just magically happen across empty space. If I want to push you, I have to touch you. If an electron wants to push another electron, it has to throw something at it. It has to send a messenger. And do you know what that messenger is? A photon, a particle of light. I don't mean the visible light you see with your eyes. I'm talking about the carrier of the electromagnetic force. When your atoms push against the table, they are literally trading a blizzard of virtual photons to transfer that momentum. Think of 2 people on an ice skating rink. If one person throws a heavy medicine ball to the other, the thrower slides back and the catcher slides back. They move apart without ever touching. That medicine ball, that is light. Every push, every pull, every friction burn, every chemical reaction, it is all just a game of catch played with light particles. So, if physical change requires atoms to push each other, and atoms can only push each other by exchanging light, then without light, nothing can push, nothing can pull, nothing can change. And this is where it gets weird. Because if we turn off the ability to exchange those photons, the universe doesn't just stop moving, it breaks. Think about this. Imagine we have a magic switch. This switch doesn't turn off the sun, it doesn't turn off electricity. It turns off the electromagnetic interaction. It turns off the ability for charged particles to see each other. It deletes the photon. Click. What happens? Most people assume the universe would just go dark, like turning off the lights in your bedroom. You'd think gravity would still pull you down, right? You'd think your heart would beat one last time? Wrong. The instant you flip that switch, reality dissolves. First, your body. Your body is held together by chemical bonds. Atoms sticking to other atoms to make molecules. Molecules sticking to other molecules to make cells. What holds those bonds together? Electromagnetism, the attraction between positive nuclei and negative electrons. The moment the electromagnetic force vanishes, every single chemical bond in your body instantly snaps. You don't explode, you don't crumble, you just cease to be a solid object. You become a cloud of monoatomic dust. But it gets worse. Think about friction. Friction is what stops your feet from sliding through the floor. Friction is what allows a car to turn. Friction is electromagnetic. Without it, everything slides forever. Think about light itself. Light carries information. It tells your eyes that a car is coming. It tells your skin that the sun is hot. Without light, no information can travel between atoms. You might think I'm exaggerating. I'm not. In this dark universe, nothing can push anything else. One atom can pass right through another like a ghost. Matter becomes transparent to itself. If matter cannot interact, it cannot change state. If it cannot change state, no events can happen. The universe becomes a collection of lonely particles drifting through the dark, unable to touch, unable to see, unable to change. So, here is the terrifying question. If nothing changes, did time stop? If I freeze a movie on a single frame forever, is the movie still playing? No, the movie is over. Here's the thing. The universe is lazy. It only does what it has to do, and it only calculates time when it needs to process an interaction. If we remove the force that causes 99% of all interactions in the universe, we remove the need for time. We remove the tick. But wait, you might say, okay, but my watch is mechanical. It uses a spring. It doesn't use light. Wrong. Let me show you why your mechanical watch is actually powered by light. Now look at your hand again. It's lying to you. You see a solid object. You see skin. You see muscle. You see bone. But you don't see the battery that powers it. And that battery is pure, unadulterated light. Let's take that mechanical watch you're so proud of. The one with springs and gears. You wind it up and the spring stores energy. As it unwinds, the gears turn and the hands move. See, you say? No light involved, just mechanical energy. Wrong. Where did the energy in that spring come from? It came from your muscles when you wound it. Okay, where did your muscles get the energy? From the food you ate, from the chemical bonds in sugar and fat. And what holds those chemical bonds together? Electromagnetism. The energy stored in that spring isn't magic. It is potential energy stored in the arrangement of atoms. Specifically, it is the tension between the electron clouds of the metal atoms pushing against each other. When you wind the spring, you are forcing those electron clouds closer together against their will. You are storing energy in the electromagnetic field. When the spring unwinds, it releases that energy. It pushes the gears. And how do the gears push each other? Electron repulsion. Without the electromagnetic force, the spring would just pass through itself. The gears would pass through each other. The watch would dissolve into a cloud of metal vapor. Hold that thought. We need to break it. Because this applies to everything. Your heart beating? That's muscle contraction triggered by electrical impulses. Electromagnetism. A car engine? Exploding gas pushing a piston. That explosion is a chemical reaction releasing energy stored in molecular bonds. Electromagnetism. A burning candle? Wax molecules breaking apart and reacting with oxygen, releasing photons as heat and light. Electromagnetism. Even your brain thinking, is he right now, is just neurons firing electrical signals across synapses. Electromagnetism. Every single process that marks the passage of time, every tick of a clock, every beat of a heart, every thought in a brain, every sunrise, every season, is fundamentally driven by the interaction of charged particles via the electromagnetic force. So, if you remove the ability to exchange photons, you remove the ability to store energy. You remove the ability to release energy. You remove the ability to move matter. You remove the ability to think. That's not a coincidence. That's the rule. In a universe without light, there is no chemistry. There is no biology. There is no mechanics. There is only gravity and the nuclear forces, which operate on scales so vast or so tiny that for all human purposes, time as we know it ceases to exist. So, if time is just a measure of change, and change is driven by light, does that mean you are made of light? People say time flies. Physically, that's impossible. Time doesn't fly, it ticks, and you are the ticking. Let's go back to high school biology. You learned that your body is a machine, a complex machine made of cells, cells made of proteins, proteins made of amino acids. What is happening inside those cells right now? There's a little protein called kinesin. It's a tiny molecule that literally walks along filaments inside your cells, carrying cargo. It uses chemical energy, ATP, to move its little feet. How does it take a step? It changes shape. When it binds to an ATP molecule, the electromagnetic forces within the protein shift. Positive charges repel positive charges. Negative charges attract positive ones. The entire structure twists and snaps into a new configuration. Snap, one step forward. Snap, another step. That snap happens because electrons are pushing against each other. And how do electrons push? By exchanging photons. So every single movement inside your body, every muscle twitch, every nerve impulse, every cell division is fundamentally a series of electromagnetic interactions. But wait, there's a catch. Your brain is the ultimate clock. It doesn't perceive time directly. It perceives change. It processes a stream of sensory data, sight, sound, touch, and stitches it together into a coherent narrative. I am here. I was there. This happened before that. How does your brain process data? Neurons firing. What is a neuron firing? It's an electrical signal traveling down an axon. It's ions, charged particles, rushing across a membrane. It is electromagnetism. If you could stop the electromagnetic force, your brain would instantly cease to function. Not die, just stop. The electrical signals would vanish. The chemical neurotransmitters would dissolve. The very structure of your brain would fall apart. If you understand this next part, you understand the entire universe. You are not an observer of time. You are a process of time. You are a collection of chemical reactions ticking away in a rhythmic sequence, and every tick is powered by the exchange of light. If the light stops, the reactions stop. If the reactions stop, you stop. If you stop, time stops for you. So, when we say time requires light, we aren't just being poetic. We are being literal. Your biological clock is an electromagnetic clock. Your consciousness is an electromagnetic phenomenon. Your perception of reality is built on the speed at which light can travel between your neurons. Which brings us to the most mind-bending question of all. If everything inside you runs on light, and light has a speed limit, does that mean the speed of light is actually the speed of time? Wait, stop. You know the speed of light, right? 299,792,458 meters per second, the cosmic speed limit. But have you ever asked why? Why that specific number? Why not infinity? Why can't things happen instantly? Here's the thing. The speed of light isn't just the speed limit for light. It is the speed of causality. It is the maximum speed at which any cause can have an effect. If the sun exploded right now, we wouldn't know for 8 minutes and 20 seconds. Gravity would keep pulling us. We'd still see it shining. For those 8 minutes, the sun is gone, but its effect hasn't reached us yet. This is where your intuition fails. Imagine you are standing next to a friend. You reach out and push them. How long does it take for your push to reach them? Instantly? Wrong. It takes a tiny fraction of a nanosecond for the electrons in your hand to repel the electrons in their shirt. That force travels at the speed of light. It's fast, but it's not instant. Every single interaction in the universe has a delay. Every chemical reaction, every thought, every heartbeat. This delay is what creates time. Think about a computer processor. A 3 gigahertz processor can do 3 billion operations per second. It can't do infinite operations. It has a clock speed. The universe has a clock speed, and that clock speed is c, the speed of light. If light traveled instantly, if c was infinity, then everything would happen at once. All events would occur simultaneously. There would be no before and after. The Big Bang and the heat death of the universe would happen in the same instant. So time only exists because light takes time to travel. Time is the gap between cause and effect. It is the latency of the universe. If you understand this, you understand the entire universe. Without that delay, without that finite speed limit, events would pile up on top of each other. The universe would be a single frozen moment of infinite density. But because light has a speed limit, events are spread out. Things happen in order, one tick after another. So the speed of light isn't just a number. It is the metronome of reality. It dictates how fast the universe can process change. But wait, what about gravity? Gravity isn't light. Gravity bends space itself. If we turn off the light, does gravity stop? Or does time keep ticking in the dark, driven by a force we can't see? So we've established that almost everything you experience is electromagnetic. But what about the big stuff? What about gravity? Stop. Don't scroll. This is where most people get tripped up. Gravity is the warping of space-time by mass. You sit on a chair and you bend the universe around you. The Earth pulls you down. Does gravity need light to work? No. If we turned off the electromagnetic force, gravity would still be there. The Earth would still pull you. The sun would still pull the Earth. But here is the catch. Without electromagnetism, there is nothing to push back. Remember? You are sitting on a chair because electrons in your butt are repelling electrons in the chair. That is electromagnetism. If that force vanishes, gravity wins instantly. Click. The chair offers zero resistance. The floor offers zero resistance. The earth offers zero resistance. You wouldn't just fall through the floor, you would fall into the earth. And the earth would fall into itself. Every atom in your body, every atom in the earth would collapse inward under its own gravity. Without the electromagnetic force to hold atoms apart, matter would crunch down into a tiny superdense point, like a black hole but without the event horizon, a naked singularity of mass. Now watch what this implies. In this gravity-only universe, time still exists technically. Things are moving, matter is collapsing. But it's a very boring kind of time. It's a one-way trip to a single point. There is no chemistry, there is no life, there is no complex structure, just a relentless accelerating collapse. And once everything has collapsed, once all the matter in the universe is a single point, time stops. Why? Because nothing else can happen. No more events, no more change, just a static point of infinite density. So gravity can move things, but it can't build things. It can't create complexity. It can't create a clock. To have a clock, to have a universe where things happen over and over again, you need a force that pushes back. You need a force that creates structure. You need a force that creates cycles. You need light. But there is one more player in this game. One more reason time moves forward and never backward. Entropy. And guess what entropy needs to do its job? If I play a video of an egg shattering, you know it's forward in time. If I play it backward, the egg reassembles itself. You know that's impossible. Why? Physics doesn't care. Gravity works forward and backward. Electromagnetism works forward and backward. But there is one thing that only works in one direction: entropy. Entropy is the measure of disorder. The universe always moves from order to disorder, from a neat egg to a messy puddle, from a hot coffee to a lukewarm room. This is the arrow of time. It is the reason time moves forward. But hold on. How does entropy increase? How does energy spread out? Let's look at that coffee cup again. It's hot. The air around it is cool. Over time, the heat leaves the coffee and warms up the room. Entropy increases. But how does the heat leave? Conduction, convection, radiation. Let's break them down. Radiation? That's literally emitting infrared photons. Light! The coffee is glowing with invisible light, sending energy into the room. Conduction? That's the hot coffee molecules bumping into the cool cup molecules. And how do molecules bump? Electron repulsion, electromagnetism. Convection? That's hot air rising. Why does it rise? Density changes. Why does density change? Molecules moving faster and pushing each other apart. Pushing with what? Electromagnetism. Stop. Do you see the pattern? Entropy is the tendency for energy to spread out. But the mechanism for spreading that energy is almost entirely electromagnetic. Without light, without photons to carry energy away, without electron repulsion to transfer kinetic energy, heat cannot flow. If heat cannot flow, entropy cannot increase. If entropy cannot increase, the arrow of time breaks. Imagine a universe where heat stays trapped forever. A hot spot never cools down. A cold spot never warms up. Chemical reactions never finish. Life never evolves. In that universe, the past looks exactly like the future. And that sounds impossible until you see the trick. Time isn't just stuff happening. It is stuff happening in a specific direction. And that direction is dictated by the flow of energy. And the flow of energy is carried by light. So not only does light create the ticks of the clock, interactions, it also creates the direction of the clock, entropy. Without light, time has no motor. And without light, time has no arrow. It would be a stagnant, frozen, directionless existence, which leads us to the ultimate end, because one day the light will go out. Not the force, but the energy. Close your eyes. Imagine 1 trillion years from now. The last star has burned out. The last black hole has evaporated. The universe is empty, cold, dark. This is what physicists call the heat death, or, more accurately, the big freeze. Wrong. It's not a freeze. It's a state of maximum entropy. In this future, every single particle in the universe is spread out so far apart that they will never interact again. Photons are still flying through space, but they will never hit anything. Electrons are still spinning, but they will never repel another electron. Think about this. If nothing ever interacts again, does time still exist? If I have a clock that never ticks, is it a clock? If I have a universe where nothing happens, is it a universe? In this dark, empty future, time technically still passes. According to general relativity, space-time still exists. But practically, meaningfully, time is dead. Why? Because time is a measure of change, and change requires energy to flow, and energy flows via light. When the last photon hits the last atom, the universe takes its final breath. The movie ends. The screen goes black. But wait, what if we could reverse it? What if we could gather all that light back up? What if we could wind the clock back? Here's the part nobody tells you. You can't. Because every time you use light to do work, every time you burn fuel, every time you think a thought, you are increasing the total entropy of the universe. You are spreading energy out. You are spending the universe's battery, and that battery is made of light. When you look at the sun, you are seeing a giant fusion reactor converting mass into energy, converting matter into light. That light travels to Earth. It hits a plant. Photosynthesis captures it. You eat the plant. You burn the energy. You move. You think. You live. You are running on sunlight. Your entire existence is just a temporary delay in the journey of a photon from the sun to the emptiness of space. You are a biological machine designed to capture light, use it to create order for a little while, and then release it back into the universe as heat. So let me say that again. You are not an observer of time. You are a participant in the flow of light. And when the light stops flowing, time stops meaning anything. But there is one final beautiful twist, a secret that changes everything about how you see yourself. So far we've learned that time isn't a flowing river, it's a sequence of events. That every physical event, from a clock ticking to your heart beating, is driven by electromagnetic interactions. That the speed of light isn't just a limit, it's the processing speed of reality. That entropy, the arrow of time, is carried by light. But here is the final shattering truth, the one that will change how you see the world forever. Close your eyes one last time. Imagine you are a photon, a particle of light. According to Einstein's theory of special relativity, if you travel at the speed of light, time stops. For a photon, the moment it is created in the heart of a star and the moment it hits your eye 1,000,000 years later happens simultaneously. To a photon, the entire history of the universe is a single instantaneous event. It is born, it dies, in the same tick. But for you, made of heavy atoms, dragged down by mass, slowed by interactions, time stretches out. You are not light, you are matter. And because you are matter, you cannot move at the speed of light. You are forced to experience the delay. You are forced to wait. Think about this. Your entire life, your memories, your future, every second you experience, exists in the gap between the speed of light and stillness. You are living in the echo of the Big Bang's flash. We started this journey by asking if time moves because of light. The answer is yes, but it's more profound than that. Time exists because we are slow. If we were light, there would be no time. There would be no waiting, no aging, no distance. Everything would be here, now, forever. But we are not light. We are the things that get in the way of light. We are the obstacles. We are the friction. And in that friction, in that resistance, in that beautiful, messy, slow dance of atoms pushing against atoms, life happens. So the next time you look at a clock, don't see it as a machine counting seconds. See it as a machine processing light. See yourself as a being made of frozen light, interacting with other frozen light, creating a temporary, beautiful pattern in the void. Time is not an enemy. Time is not running out. Time is just the universe's way of keeping everything from happening at once. It is the patience of light. And without light, without that fundamental force connecting every atom in your body to every star in the sky, there would be no now. There would be no then. There would be no you. So turn on a light, watch it fill the room, and realize that you are looking at the very heartbeat of time itself. Thanks for watching. If this shifted your perspective, click that like button so the algorithm shares this light with someone else. And subscribe for more deep dives into the physics of reality. See you in the next one.